Dr. Kim Cuddington she's an associate professor in the Department of Biology. And oh, is somebody recording?
Oh, I just started recording. Is that okay, Mary?
Yeah. Perfect, thank you. Okay, yes, carries out research in theoretical and population ecology. Her mathematical models have been used to predict how and when species become invasive, as well as describe the role species play in ecosystem engineering. In her teaching, Kim works to engage students actively in their learning to see the importance of numeracy skills and contributing to the field of ecology. Deborah Andrade Pereira is a PhD candidate in the Department of Biology in Kim's lab, where she researches impacts of neglected climate change phenomena to plant populations and invasion risks in North America. Her interests also include science education, and her master's was focused on making science more accessible to culturally diverse undergrad population. Zitao He is a PhD candidate in applied math at the University of Waterloo under the supervision of Dr. Chris Bauch. Zitao's research interest lies in the intersection of population dynamics and epidemiology, data-driven dynamical systems, and application of evolutionary game theory. His current research focuses on critical slowing down in online social media and social networks in coupled behavior disease systems. Eddie Wu is a first-year master's student in the Department of Biology in Kim's lab, where he works on predicting the population growth of invasive black carp in North America. He is interested in finding the underlying mechanisms behind the latitudinal variations in black carp at sexual maturity and how it can be applied to population growth predictions. He's also passionate about teaching and learning from peers. He believes participating in this OER project to produce an educational platform that could be beneficial to other researchers and students is a great way to communicate knowledge. So with that, I will let you folks take it away. Thanks. These guys have a video presentation, so Deborah will be getting it up to share.
Just a second, please.
Yeah, and we will have, if you can type questions in the chat as you go along, or you can wait till the end, and these guys, they'll all be here to answer questions when they're finished with this presentation.
I will close and open the video again because it's not showing as an option for sharing. Just a minute, please.
That's what we get for testing it, right? We should have just left it up there. All right, there you go. Yeah, and maybe if you can make it into a full screen. Yeah.
We're going to talk about an open educational research resource project that we have engaged in, and in the process of having a biology graduate course. So I'm the instructor for the course, Kim Cuddington, and my co-presenters today are students in the course, Deborah, Eddie, and Zitao. First off, we'll be providing a very brief review of course-based research, and then we'll talk about how our graduate course is a course-based project in OER. And since the course is ongoing, we will then talk about what we've learned so far. The inspiration for this project is a recent paper by Trust et al., which we will be referring to throughout the talk. So first off, course-based research. This is where whole classes of students address a single research question. And that is interesting because it's a real research question, something of interest to scientists and the community members. These kinds of courses were created to allow scaling of research experience for large programs like biology, where there's literally thousands of students, and we can't accommodate a traditional professor-student mentor-based research experience. These course-based research experiences seem to allow for greater engagement of the students because they're dealing with a real problem. They engage in the scientific process, so they fail, they troubleshoot, shoot, and solve problems and repeat. They require a range of related skills, so not just the course content, but they might be doing things like collecting data, etc. There's hundreds of examples of this type of course design. I've put a few links down here. But when you go to take a look at examples of this at the graduate level, there is not much at all. And in fact, most of the examples that I found were cases where the graduate students were creating open educational resources. So this was what I would call a project-based course for graduate students. And the ways that it would differ from a graduate course that's typical in biology has to do with the additional parts of it. So typically we have reading courses or technique courses. Reading courses, the students engage with the literature, analyze the content of papers. Techniques-based courses, they learn how to do something. So a stats course is a really good example of that, and they apply those skills. A project-based course would require both of these things, but the students might be curating the content, so selecting the materials that will be covered. And they will also be learning skills that are not specific to the course. For example, in an OER course, they might be learning how to use a public repository. So our project for Bio 652 is to create an OER resource. And I was inspired to go this route after reading the Trust paper, where he talked about shifting the student role from a consumer to a curator of information. And he and his co-authors suggested that this increased motivation, attitudes towards learning, and supported the development of other skills. In a survey of 5 courses, the authors found that 76 reported a positive impact of OER creation or design as their course subject matter. None of them reported a negative impact, and across the different kinds of design projects, so there were some that involved contributing to a wiki, for example, various other things, those students that were engaged in creating an ebook, 100% of those students reported a positive impact on their attitude and motivation. So I proposed to the students in this course, Bio 652, that we create an OER resource. I suggested it might benefit other graduate students and early career professionals in biology, and that it would be a permanent record of their scholarship. And I also thought it might provide incentive for the students to engage with the material more deeply. The course was designed to, of course, be relevant. So the professional development aspect of it is that the students are producing educational material, which is something that if they perhaps go on to academia, they would be required to do. It includes that aspect of iteration, although in this case, it's in the sense that there are opportunities for formative comments all along the process. So the students present an outline of materials that they've chosen. They get input at that point. They incorporate that input when they create a draft of the online text. And then there's a final round of revision. This final round of revision includes comments from me and also from the project lead. So for each major section of content, one of the students acts as the lead. That person does the primary curation of material, provides an outline, divides up the material into sections that can be completed by other students, and gives feedback. At the same time that the students were producing these materials, I was too. And so some of the materials I produced then could provide examples for how you might do this in terms of coding and pedagogical techniques. So the specific output, as I said, is an ebook or an e-text. The link for finding the materials is up above, and you can see an example of the front page here. Eventually, the materials will have 3 large modules on 3 major content areas. The materials include not only the concepts, but also embedded code, R code. R is a programming environment that's widely used by biologists, and specific examples, biological examples designed to help motivate the students who are using the OER resource. So here we have some images of duckweed, which is actually an experimental organism that we use in the lab. And below the image, you can see the code that's used to analyze the data from there. I'll pass it over to Deborah, who's got more to say about the pedagogy.
Yes, So I would like to focus on a specific section we are doing as part of our educational material. So for this section, we are illustrating how a recent publication has applied population ecology theory to tackle ecological problems, for example, biological invasions or extinction risk. So these sections are composed by a short description of the publication, an illustration of the concerned organisms, codes using published population data, and also equations to create models, and finally plots, providing model projections for that specific population. So one of our examples you see here in the screen describes how an exponential growth of invasive hippo populations in South America is threatening aquatic systems because of the overload of organic matter they bring. And here, another example focused on invasive lionfish, which threatens the biodiversity of invaded areas. This shows that the number of lionfish living at the same time controls the population sizes for these species, and this has implications for management planning. And reading those recent publications and developing a section in our educational material has helped our learning in the following ways. So we can better understand concepts and equations by applying models to real-world data. We recognize the importance of ecological theory to understand and manage current problems, and this helps us also to become familiar with relevant literature.
So the course is still ongoing. We started in January, but we'd like to share some of the things that we think we might have learned so far. Some of the difficulties. The course topic, population modeling, requires programming, math, stat skills, as well as the conceptual content. And we are combining all of that with the additional task of creating the OER materials. And so there's a lot going on here and multiple skills and requirements. So that's a bit overwhelming. In addition, the students have noted that creating materials to teach others requires a lot more reading and a lot more literature than just proceeding with an ordinary course where the materials have already been curated. There do seem to be some benefits, at least from my point of view, though. The students are learning skills that have to do with open science in terms of using formats that are easily available, like Markdown, using versioning on GitHub and a public repository. And those are skills that they would absolutely need to do scientific research. In addition, there's some development of teaching skills. Students have mentioned that they need to identify with learners who are far less familiar with the topics in order to create reasonable materials. And from my point of view, it's great to have a permanent record of this scholarship. Eddie's going to talk about some coding skills.
Right, so as a student author, I like to share some previous experience gained from participating in this OER project. So like you mentioned, we are using R Markdown as the main tool for developing the material. In this process, I did a lot of important coding skills that are going to be quite helpful for my own research. So the first, which I'm going to talk about, is the graphic skills. So graphs and figures are provided in many sections for demonstrating some important concepts. However, copyright laws prevent us from copying or directly using graphs created by the other authors. So as a result, we need to reproduce those figures in our own selves. During this process, I learned not only many useful tricks and important skills for graphic coding, but also the process of recreating a graph through coding also deepens the understanding of the material. Because you really have to understand the logics behind a formula or a concept to successfully reproduce a corresponding figure for that concept. Finally, graphs in the OER material should be presented in a way that makes them easy to read and comprehend. So below here is an example of two graphs from different versions of our material. So the left graph is created in the first draft and the right one is in the final edition. Although both graphs are demonstrating the exact same concept, that is the small difference in initial population size can cause the population projection to vary dramatically. However, the graph on the right is more visually appealing, as you can see. So with the lines superimposed on each other with different colors, and also with the larger font size and the legend size, the readers can can easily see the difference in this population more clearly. And also compared to the first graph, the second one is appearing to be better in formatting and everything else. So another important skill is the R markdown skills. Yes, so when developing the material, we constantly need to compile the MD files into different formats for demonstration and presentation, such as the HTML, PowerPoint, and even PDF. So since different sections of each module are divided among the authors, so version control is necessary and important. And finally, we also use the BibTeX files to do the citation and the bibliography. Although those technical skills are not difficult to learn, but they are all quite new to me as a new grad student. So as a student author of this project, acquiring those skills as byproducts from developing the material are also super helpful, because they are potentially benefiting me in my own research as well.
So in summary, there's definitely benefits to having an OER project as a grad course. Students are developing professional skills that'll be related to perhaps their future in teaching, certainly their future in scientific research. And that's beyond the stated objective of the course of obtaining mastery in population modeling. And certainly this should provide a permanent public resource of the materials that have been curated by these students. But of course, there's a cost, and that cost is the workload associated with these benefits. And so when I think about whether I would do this again, my answer is yes. I think it's a really valuable course design, but I would include a smaller section of material. And I certainly would scaffold the material. So my idea is to have 3 sections, where the first section is an example of previously created OER materials that are appropriate for the course. The students learn the concepts from that material, but they also start critiquing the design of the OER materials. And then a second section where there's partially completed materials that the students populate, so that there's, again, simultaneously learning material, but also practicing the technical skills required to set up the OER resource, and practicing writing materials, curating materials, and designing materials. And then finally have a mastery type wrap up, where the students do the design from beginning to end on the last section of material. And let's hear from the students. Would they do this again?
I think I'll go first. Yes, definitely. As an applied math student, I'm an exact member of this group, and I really enjoy collaborating with people from very different academic areas, because we approach a problem in very different ways. And in this course, I really benefited from the biological knowledge and insights from my colleagues.
I also enjoyed working with my classmates and instructor as we designed a collective material. I think it has been really difficult to engage with classmates, either due to the distance resulting from living in a pandemic, or due to the individual nature of many course assignments. So I would surely do it again.
Yeah, so I agree with Zita and Deborah on the collaboration aspect of this project. And also, my hope that the material we produce will be available online and help other fellow researchers in our same field. Makes me very excited in this project. So yes, I would definitely choose to do it again.
So thank you very much. And I think we should have some time for questions in real time.